Hey everybody, Mr. Delarusso here, and this is a review on geometry, chapters 1 and 2, and a little beginning of chapter 3. Let's go ahead and begin. If angle A and angle D are supplementary angles, and A is 5x, write an expression to find D. Okay, well if they're supplementary angles, that means they add up to 180. Remember, complementary is 90, supplementary is 180. So put in 5x and then subtract 5x from both sides, and you get 180 minus 5x. Okay, if x represents an odd integer, which of the following would represent an even integer? Okay, pick any odd integer, 1, 3, 5, 7, 9, any one of them, you guys. I think I picked 5. And then and just plug them in, you guys. So just pick an odd integer and plug them in to see which one's going to give me the even. Only one of them will. If I did 5 plus 2 right there, that's 7. That's odd. 2 times 5 is 10. 10 minus 1 right here. 2 times 5 is 10. 10 minus 1 is 9. That's odd. I'm looking for which one's going to get me an even integer. Okay, so when I do all of that, let's see. The only one that I get is an even integer is when I plugged in an odd number right here. I get 25 plus 1 is, or I'm sorry, plus 1 is 26. Whoops, I made a mistake here. Nothing new. I make mistakes all the time. So if you guys are in my class, you see me do this all the time. Okay, and I tell them I'm just checking to see if you're paying attention. Okay, the transitive property. Okay, the transitive property, let me save this, you guys. Save, save. Okay, the transitive property. If x equals y and y equals z, then x equals z. Notice this y right here has to pick up with this y. Sorry for that distraction there. Okay, so if x equals y and y equals z, then this x over here is going to equal this z right there. Then x equals z. That's the transitive property. You might see the symmetric property. They just flip around the equal sign. If x equals y, then y equals x. Okay, let's see. All right, so identify each pair of angles. All right, we got all these angles right here. Let's look at 1 and 7. Okay, 1 and 7, they are alternating on this transversal. Here's the transversal. They're alternating, and they're outside these two lines right here, so they're alternate exterior angles. Okay, all right, and then let's take it 3 and 8. Okay, these guys are inside the two lines, and they're on the same side of the transversal. I had an old book that called them same-sided interior angles, but my book now calls them consecutive interior angles. If they're both on the same side of the transversal and they're both inside, so they're called consecutive interior angles. Okay, you can abbreviate. All right, 8 and 6, well that's easy. Those guys are called vertical angles when they're opposite each other like that. They're vertical angles. 4 and 8. Okay, here's 4 and here's 8. Okay, those guys are corresponding. One's an outie, one's an innie in between the two lines right there. And if you just could slide this line over on top of this 4 would slide right on top of that 8. That's how I remember corresponding angles, okay? And then 2 and 8. Where's 2 and 8? Okay, 2 and 8, they are alternating on a transversal. They're inside the two lines, so alternate interior angles. Okay? Okay, what's the first number in the sequence? Okay, when you see this, you guys, well, they're not adding the same amount, so they're probably multiplying. So let's take this number and divide it by this number and see what we get. Okay, and I get 3, 486 divided by 162, and then I check to see if I get 3 again. So 162 divided by 54 is 3 again. So it's going down by division of 3. So if I go 154 divided by 3, I get 18, and then 18 divided by 3, I get 6, and finally 6 divided by 3 is 2. So the first number in that sequence is 2. Okay, and if we went to the right, it went times 3, times 3, times 3, times 3, times 3, times 3, times 3. So going to the left is dividing. Okay, the measure of one angle is 72 degrees more than its complement. What are the measures of the angles? Okay, so if 1 is 72 and supplement, I'm sorry, did I say complement? Supplement is 180. So I'm going to go x plus 72 because 1 is 72 more than the other one equals 180. Okay, and then you go ahead and combine like terms and you end up getting x equals 54. Okay, that's one of them. Don't forget the other one is 54 plus 72 because it's x plus 72. Here's the other one, x plus 72. So I get 126. So 54 degrees and 126 degrees are the two angles. Okay, in the figure, ABC is 160. So here's ABC is 160. So that means this angle right here plus this angle equals the total angle 160. So 2x plus 46 plus 70 equals 160. Okay, end up getting x equals 22. Now be careful, a lot of times x is not the answer, and I saw a lot of kids leave it at that. So it's asking up here, what's the value of angle ABD? Okay, so ABD is 2x plus 46, so I got to plug in 22 right there. So 22 times the 2 is 44, and 44 plus 46 is 90, so that angle's 90. It doesn't look like a very good 90-degree angle, but if I did my math right, it should be 90. Okay, so then solve and give reasons for each step. Okay, so it doesn't just say solve, it says give reasons. Okay, what I tell kids when I'm teaching algebra is to multiply everything by a common denominator to get rid of fractions. So this one is 3, so I'm going to go this times 3 times 3 times 3, and then this times 3 right there. I just multiplied by 3, okay, that's given. Now I'm going to multiply by 3, and it's called the multiplication property. I multiplied by 3. Let's clean it up. So this is just simplifying here. 3 times 2x is 6x, 3 times 5 is 15. That's 9. The 3's cancel, so we're left at 2x. Okay, now I'm going to take away, I'm going to subtract 2x from both sides. So 6x minus 2x gives me 4x. All I did is subtract 2x from both sides, so I used the subtraction property. Okay, again, now I'm going to subtract again. I'm going to subtract 15 from both sides. 9 minus 15 is negative 6. Okay, now I'm going to divide both sides by 4. And then negative 6/4 reduces to negative 3/2. And so that would be division property because we divided both sides by 4. And there it is. Now if you wrote negative 1.5, that's okay. But I want this stuff too, you guys. I want these reasons right here. Okay? So let's try this. Find the area and perimeter. Okay, the area, I think I'm doing the perimeter first. I'm just going to add up all those lengths right there. Okay, so just add up all the fractions. They're already common denominators, so 12/7 inches. Okay, or 1 5/7, I don't care. Area is 1/2 base times height, so I'll go 1/2 this base times this height right here, and then cancel where you can. I think this 2 and this 4 can cancel, yeah, and that's what I did. And I got 6, this leftover 3 times 2 is 6/49, and area is always in units squared, so this would be in inches squared, so 6/49 inches squared. My air conditioner came on, that's what the noise is in the background. All right, here's a proof right here. So given C is the midpoint, okay, the midpoint always divides segments up into equal segments. So I'm going to say equal segments in here somewhere. AC equals CB. In fact, there it is right there. So this is going to be definition of a midpoint. All right, and then what else does it say? Oh, we also have DC is congruent to CB. Okay, so this segment is congruent to this segment right here. Okay, so prove that AC is congruent to CD, or sorry, equal to CD. All right, so this is given. That's obvious right here. That was given right there. Let's go ahead and throw this down. Here's the other given. It's hidden in there. Remember, that's up here. That's given. So let's go ahead and put that in there. That's given also. Free points. Hooray! All right, now when I just change congruencies to equals, and I don't have the segment bars on this one, so it changes to an equals. That's just called definition of congruency. If they're congruent, they're equal, and if they're equal, they're congruent. So when you see it go from here to here, or sometimes it might go from here to up here, definition of congruency. Okay, so now I have DC equals CB, okay? And then C is the midpoint, so now I'm going to use the definition of a midpoint. Since that's the midpoint, then AC is going to equal CB, definition of a midpoint, and that's what this says right here, AC equals CB. Okay, now check it out, you guys. Right here I have DC equals CB. Here I have CB equals AC. Well, can't I use the substitution property now? And since CB is right here and right here, I can substitute in this DC in for that CB right there. My book's starting to say transitive property. I don't like transitive property on this because it's really not the transitive property. It's more of the substitution property. But I'd take it if you wrote transitive because my book's doing that also. Okay? So it's sort of a form of transitive. See how the CB is CB right there? So they substituted in this DC in for that one right there. DC is the same as CD. Okay, same thing. All right, so there's a proof right there. Now let's see. So angles ABD and DBC are a linear pair. Let's draw that first. Okay, there's a linear pair. ABD, linear pair means they make up a straight line. So ABD and DBC make up a straight line. Then I put in 3x plus 2. This should be a plus 2 right here. Okay, and then x minus 26. Okay, I think I got it on the next one there. Yeah, I do. All right, so straight lines equal 180, so I went ahead and added those up to make them 180 and got x equals 51. Okay, now that's not the answer. X is almost always not the answer. Plug in 51 right here and 51 right here, and I end up getting 155 degrees and 25 degrees. All right, almost done. Okay, so tell whether each relationship is true or false. Okay, given these markings right here. Okay, I got a perpendicular lines right there. All right, it looks like this line is parallel to this line, but since there's no arrows on here to tell me that, I cannot assume they are. Just because they look like they are, we can't assume. I can assume that's a right angle right there, so I got a right angle right there. So BC, here's BC up here, is perpendicular to AE. No, These guys are perpendicular. BD is perpendicular to AC. So this is true. 3 is true. 1 is false. Okay, E is the midpoint of BD. Whoops, I forgot to put my segment on top of BD. E is the midpoint of segment BD. All right, that's not true. All right, so here we go. So that's false, that's false. This one was true, okay? And then finally, this is false because they look like they're congruent. Angle BAC is where my cursor is. Angle BAC, so it's this angle right here. And angle DCA is this angle. This angle looks like it equals this angle, but I can't assume it is because they didn't tell me that this line was parallel with this line. So that's why that one's false right there. All right, and that's it. Take care, you guys. Good job.